Now we haven't graphed the tangent function, so we're going to have to do that first in order to see what the reciprocal cotangent function would look like. So I'm going to choose strategically some nice concrete points that will give me some nice values to plot on my Cartesian plane. So, we have all of these points we could use, or I should say angles. But like we talked about how sine is the definition, tangent is the definition of sine over cosine. I don't really want to deal with plotting radicals because they're irrational and it's hard to plot on a graph. So I'm going to conveniently choose 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and then the last one will be 7 pi over 4. And the reason I did that is because if you're at 0, so remember again, your tangent function, its definition is y over x, or in terms of sine and cosine, it's sine divided by cosine. Or to bring us back to one of the first days we met, it is opposite over adjacent. So if I do this, it would be 0, that's your sine, right? Divided by 1. So my tangent function gives me 0 here. At pi over 4, so you'll see why I conveniently chose that angle, is because when you divide root 2 over 2 divided by root 2 over 2, life is nice to us. It just gives us 1, right? The same thing over the same thing gives us 1. Here, well, now it's going to be 1 divided by 0. That I can't divide by 0, so it's undefined. 3 pi over 4, here's that nice thing again. It's root 2 over 2 divided by negative root 2 over 2, so that's going to be negative 1. Pi, it's going to be 0. 5 pi over 4, it's negative root 2 over 2 divided by another negative of those, so that's why I'm going to get positive 1. 3 pi over 2, it's going to be negative 1 divided by 0, can't do that, so it's undefined. And our last one, 7 pi over 4, it's going to be negative root 2 over 2 divided by root 2 over 2, so it gives me negative 1. So I have some nice coordinates to deal with, kind of make my life a little bit easier. So I'm just rewriting these as coordinates. All right, I'm going to go down to our Cartesian plane, and I'm just going to go ahead and plot them actually. So 0, 0. And I conveniently chose that, these are increments. This is pi over 4, pi over 2, 3 pi over 4, and then a full pi. So my next coordinate is pi over 4, 1. So that would be right here. My next coordinate is pi over 2, undefined. So here we are. Undefined, give myself an asymptote. Okay, then my next one is 3 pi over 4, negative 1. So I'm here. Then I get pi 0. Good. Then I get 5 pi over 4, 1. And then I hit that thing again. 3 pi over 2 is undefined. And then 7 pi over 4 is negative 1. Okay, so if I had us plot all of those coordinates, we would have a better idea what this looks like, but I'm going to guide us a little bit more. There's going to be another asymptote here because remember our period is pi. So these asymptotes are happening pi units apart. This would be negative 1. So we end up getting something. Remember, skim that asymptote, comes up here, and then it skims it. Now, remember, our period for tangent, which we talked about, is pi. So every pi units, these beautiful waves are going to happen. Let me get a little bit, it'd be like this. So I'm going to have to cut it off a little bit. And then, okay, if this is here, we know another asymptote has to be here. All right, so we get this, this, and this. Again, just because it keeps repeating itself. So this is what your tangent graph looks like. All right, so now, if I was going to do this good old cotangent function, again, I'm going to keep all of my angles the same for convenience. And now, remember, we go ahead and find the reciprocal of those outputs. So if I flip 0, I have undefined. Flip 1, I get 1. Now, this is the interesting thing we talked about in a previous lesson, but when you flip undefined, so think about that. That's the same thing as saying 1 over 0. If you flip that, it becomes 0 over 1, so it becomes 0. Flip -1, it's just -1. Flip 0, undefined. Flip 1, 1. There's that idea. Okay, undefined means you're dividing by 0. So if you take the reciprocal, 0 is now on the numerator, so it gives you 0. And your last one will be -1. So here are some other coordinates we can plot. So I'm just sitting here listing all of these. All right. And now I'm going to go back down to this graph. And I can use these coordinates I came up with, or I could even just look here, which is kind of convenient. So where I have zeros, I will have asymptotes for my cotangent graph. So here's another 0, so that will be an asymptote. There's another 0. Now, when we flip these, or I can go straight back to this, we get pi over 4, 1. So pi over 4, so that makes sense. That's going to stay there. So hopefully it makes sense. I can keep going back to that chart, but when all these ones and negatives ones are going to stay put. And then we have this as an asymptote. Now here's the other interesting thing is, and we have it in our chart, okay, so you can refer to that chart, but I like to also talk about visually when you have an asymptote, well, that's telling you you were dividing by 0. Well, now all of those asymptotes for our reciprocal function cotangent become zeros. And so what our graph looks like for cotangent, it's pretty darn similar to tangent, except your asymptotes are happening at different places. And that wave looking thing is happening in another direction. So that looks a little confusing, but kind of pretty actually. But I'm going to go ahead and always label. This is our cotangent graph, this purple graph. It's kind of hard to see, but that blue, if we read left to right, was, well, actually, let's talk about it in mathematical terms. Blue is increasing the whole time, while the purple, the cotangent graph, is decreasing the whole time. So what I'm going to do is I'm going to take away the blue graph tangent because that's not part of my cotangent graph. I just used it to help me figure this out. And I just didn't make a wave with that last one. holding my breath so I don't erase anything I shouldn't. And so there's your cotangent graph. So the last thing I wanted to show you is just using Desmos, just putting them in so you can see what they visually look like. Y equals, so let's just talk about, the first one we did was cosecant. So there it is, right? We came up with that on our own. The next one we talked about was secant. We came up with that on our own. And then the last two we talked about in this video were tangent. So there it is. It's always increasing, right? It goes through the origin. Where cotangent is always decreasing and it doesn't go through the origin. Again, just want you to recognize these graphs. We will not be graphing them by hand in this class. All right, see you next time.